Hello everybody, today I'll be completing the June 2022 Physics Regents. This will be part A. There will be following videos including part B and then so on. I also in another tab I have the calculator and the physics reference table in case we need to use it for any problems. Okay, let's begin. Which terms identify two scalar quantities? So scalar quantities have magnitude but no direction. So force has direction, otherwise known as a vector. And acceleration also. Impulse is a vector. Mass is a scalar and velocity is a vector. And these are both scalar quantities, energy and time. Number 2. A motorcyclist initially traveling east at 50 meters per second. Okay, so let's label that. So we have v initial equals 15 meters per second, and then we have accelerates, so 3 meters per second squared, so this is our acceleration. And then we have a final velocity of 21 meters per second east. So we're looking for the distance, right? So how far d. So let's see which equation has that, all those components. So a quick way to know is that, look, for these four equations, these are the kinematic equations, right? All of these equations use time in it, except this one, right? So do we have any time in our problem? We don't, right? We have the final velocity, we have the acceleration, we have the initial velocity, and we're trying to find the distance. So immediately we know that we use this equation. You can manipulate it, be like vs squared minus vi squared divided by 2a is equal to d. You could do that, or you could just plug it in, but for this purposes I'm just going to plug in. So vf squared, 21 times 21, that is 20 times 20, 400, 21 times 441, equals vi squared, which is 15 squared, which is 225, plus 2ad. So 2 times 3 is 6, so 6d. 441 minus 225. What is that going to be? That's going to be, I think 306. No, not 300. 441 minus 225. That's 130, 260. No. Yep. So 216. I'm going to get 216 equals 60 divided by 6. 621 3 times, lower down to 6 goes into 36 6 times, so it's 36 meters. Okay, a battery powered electric motor is used to cause the wheels. So we have a battery powered electric motor, so we have an electric motor is used to cause the wheels of a toy car to rotate. So rotation, right, that means motion. So we need, in this motor there's a conversion of, well, we have electric energy right here, right? It's electric motor, so it has to be electric energy. No, okay, it's not chemical. That's like what you see in a battery. No, we're causing this battery powered electric motor to move the toy car, so it's mechanical energy. Yeah, it's D, right? Mechanical energy is the addition of the potential energy plus the kinetic energy, but in this case, since it's level, we have no potential energy, so the mechanical energy would be equal to the kinetic energy. Thermal, no. Electrical, no. To chemical, yeah, I said that one. Okay, a projectile is launched horizontally from a height of 65 meters with an initial horizontal speed of 35 meters per second. What is the projectile's horizontal speed after it's fallen 25 meters? Okay, it's 2. Because the horizontal, in projectile motion, the horizontal speed does not change, right? Because there's no force acting on it in the horizontal direction. There's only the horizontal speed. There's no other external force, so it remains the same. In the vertical, you have gravity acting on it, and you have other forces, such as, if you include air resistance, but which means that the vertical speed is not constant. So only the horizontal is. So if we have a horizontal speed of 35 and it's asking for the horizontal speed, it will always stay the same. Question 5. Which statement best describes the motion of the block? Well, the speed is directed toward this way, right? Okay, so that means we have a force to the left, 10 newtons, and a force to the right, 10 newtons, which means that our net force, regardless of your sign convention, whether you choose this as the positive, this as the negative, this as the positive, this as the negative, you will still get a net force of 0, which means two things. It means that the block is at rest, or the block is at constant velocity. And how do we know it's at constant velocity? Why? Like, not how, but why? Because the acceleration is defined as the change in velocity. If we're keeping one velocity, that means we have no change, which means that the acceleration is 0. 0 equals m. Well, so anything has mass, so m, let's say it's 10 kilograms, times what equals 0. So 10 times 0 is 0, which means that, yeah, constant velocity will have a net force of 0. So then the block is accelerating. No, no answers with acceleration. No. It's to the right with a constant speed. Yes. Block is moving to the left with decreasing speed. No. That would cause an acceleration. The magnitude of an unbalanced force applied to a 4 kilogram crate is 10 newtons. If the magnitude is double, the inertia is unchanged. And, like, do not be confused being like F net, right, equals MA. Don't think that, okay, I double the force, I will double the mass, right? Or the acceleration. Don't be like that, because the mass, you have to know which value stays unchanged. So think of it like this. We have a 4 kilogram box, right? And we're applying a 10 Newton force. We have that same box, right? We're not doing anything. But we're applying a force double, 20 newtons. Now, the inertia means basically the matter. What is happening to the mass inside of this box? It's staying the same because we still have a 4 kilogram box. We're just doubling it, the force, right? So it has to stay unchanged. A 60 kilogram man is pushing a 30 kilogram lawnmower. Compared to the magnitude of the force exerted on the lawnmower by the man, the magnitude of the force exerted on the man, it's the same. This is just a classic question of Newton's third law, right? The force I apply to something of less mass or more mass will equal to the same force applied in the same force but in the opposite direction. Number 8. When the car is in the position shown, what are the directions of the centripetal force acting on the car and the velocity of the car? So always in centripetal acceleration or centripetal force, it will always be directed toward the center, while the velocity will always be tangent to the circle. So the velocity in this case would be going down, and the centripetal force in this case would be going to the right. Velocity, centripetal force, yes, it's this one, right? Force is directed downward, no. Number 9. An electric motor with a power rating, so let's label this. This is the power, is used to raise an elevator that newtons, so that's our force, or otherwise known as our weight. What is the total time? Okay, so we have the distance here. So what we're trying to find the time, right? So let's label this time. So what do? We see what we have here. We go to power equals work over time, manipulate the formula, multiply both sides by t, divide by p. Time is equal to work divided by power. Now, the work, we have to solve for the work, right? We have the force. Work is equal to the force times the displacement, right? So which is equal to, we have our power, so we only have to find the work and we get the answer correct. We get the question correct. Work is equal to the force, which is 2.8 times 10 to the 4th newtons times a distance of 20. Let's do that right now. 2.8 times 10 to the 4 times 20. 2.8 times 10 to the 4th power times 20. 560,000. So, okay, so it's 560,000. 560,000 is our work, joules, divided by the power, which is this, 6.48 times 10 to the fourth. Okay, so let's do this. Wait, what? To the fourth. Oh no. To the. There we go. 8.64 seconds. Yeah, it's choice C. So I manipulated the equation, and then I found the time finding the work first, and then just dividing it by the power. Number 10. A person standing on a sidewalk hears a siren of an ambulance that approaches, passes by. Okay, compared to the frequency. Okay. So this is a classic question of the Doppler effect. Now the Doppler effect says if we have an observer, and we have in this case a siren coming closer and then leaving, approaching, passing by, the frequency increases as it gets closer to the observer until it decreases when it gets away from the observer. So like if you were to imagine this, right? Like any person has heard like an ambulance or a cop car or a fire truck or anything like that. When the truck or the car gets closer to us, we hear the siren gets louder, and then when it leaves, when it goes away from us, we tend to hear the sound less, right? That's because when it gets closer to us, the frequency increases and the wavelength decreases. When it gets away from us, the frequency decreases and the wavelength increases, thus having an inverse relationship. So when the frequency increases at first because it's getting closer, and then it decreases because it's passing by and going away. So it's first higher, then lower. 11. Which particles exhibit properties of waves in some experiments? So we have EM waves, right? Electromagnetic waves. Now these are produced by accelerating electrons, so accelerating charge, and then through that we also have electromagnetic waves like light waves, right? So this is perfect. So exhibit properties of waves. Well, photons are basically particles of light. So yes, this is true, but let's see, electrons only. The problem with this is true, but we need both of them. It's not only photons or only electrons, both photons and electrons. And I gave you the example here. EM waves, they're produced by accelerating electrons, and light waves are an example of EM waves. So they both are properties of waves. The direction of the electric field at a point in space is defined as the direction of the force on a test charge. So no, not a test mass, not a North Pole, on a positive test charge, right? We want to see how the positive test charge will act on two. Let's say this is the positive plate or the negative plate. That means it's gonna go like, and then it's gonna go down, right? It's entering, and then it's gonna be repelled, and it's gonna go down. So that's how we test always with a positive charge. Test charge, yeah. A net force of 1 Newton will accelerate a 1 kilogram mass at 1 meters per second squared. Well, F net equals ma. F net equals 1 times 1, which is equal to 1. A net force of 1. This is true. This is the answer. We want to say does 1 equal to 1 times 9.8? That is not true, so it cannot be 2. Does 1 equal to... Okay, constant speed will always have a net force of 0, so 1 does not equal 0. And the same here, 1 does not equal 0. The elongation of a spring will be quadrupled if the magnitude of the force elongating the spring is... Well, the elongation, otherwise known as x, is given in this formula. Force of a spring equals the spring constant times the distance compressed or the distance elongated. So this is saying if we multiply the force by 4, otherwise known as quadrupled, what will happen to the distance? Well, it's gonna multiply by 4, right? It's in proportion. The problem with So the answer will be 4. But the difference between this one and the one we did earlier is that you have to know that the mass stays the same, right? In this case, we don't know. We don't know if the distance will stay the same, right? We don't have enough information. We only have the elongation multiplied by 4. What's gonna happen to the force multiplied by 4, vice versa. So yeah. 15. The vector diagram represents the path and distances run by a student in a cross-country race. The displacement of the student from start to finish is, well, okay, displacement is basically distance with direction. So if we have 0.8 kilometers to east and 1 kilometer, that will be 1.8. Let's say positive 1.8. This is negative 1.8, which means that the addition of this plus this will cancel out to this, right? Because this is going west, these are going east. So then what are we left over with? We're left over with 0.8 kilometers and 0.6. Add them up, you get 1.4 negative, or 1.4 kilometers south. The diagram below shows the arrangement of 3 charged hollow metal spheres, A, B, and C. The arrows indicate the direction of the electric forces acting between the spheres. Which spheres have the static charges of the same sign? Well, same sign means that they must repel each other, right? So if we have a proton and we have another proton, right? Their forces won't be like this, which means that they're attracting forces. Their forces will be like this, pushing away from each other, right? So where do we see that? These are attracting forces, so we don't want that. That means they have opposite charges, because opposite charges attract each other and like charges repel. This is good because these are repelling each other, right? Like I said here, they're repelling, they're pushing away from each other, and these are attracting. So A and C are the only charges that have the same sign. B and C have opposite, and A and B have opposite. Next, 2 small charged spheres are located distant d from each other and experience electrostatic force of attraction, Fe. If the magnitude of charge, if each sphere is tripled and Fe is unchanged, what other change must have occurred? Okay, so what formula could we use here? We could use, on the electricity set, so we could use this one, Fe equals kq1 q2 divided by the r squared, right? So Fe is proportional to q1, q2, and the spring constant always stays the same. So we could write it as this, right? Ignore the spring constant for now. Fe equals to q1, q2 divided by the radius squared. Now, if we're tripling the magnitude of charge on each sphere, which means that tripling both of them, both charge 1 and charge 2, which means that we're going to have 3 times 3 is 9 over r squared. But it says Fe is unchanged, so basically this is supposed to cancel out with this to remain. It'll basically be 1 times Fe, which is just Fe. So then we have to, r squared has to be equal to this, right? Which means that r squared equals 9, otherwise known as the distance. Take the square root. Take the square root equals 3. So the distance is decreased by a factor of 3, yes. Compared to the resistance of an aluminum wire at 20 degrees Celsius, the resistance of a tungsten wire of the same length and diameter at 20 degrees Celsius. Okay. So we have the formula. Let me find it. It says in electricity, right? Right here. Resistance equals resistivity, otherwise known as rho, times length divided by A. So let's write that down. Resistance is equal to resistivity times the length divided by the cross-sectional area. Now look, the same length and diameter, which means that the same cross-sectional area and the same area, right? Which means we can ignore those factors here. What we have to know is that R in this case is proportional to rho. So whichever one has the greater resistivity will have the greater resistance, right? So compared to the resistance of aluminum wire, the resistance of tungsten. So let's see. We look at the resistivities. So aluminum is that, and tungsten is that. Divide both of these by 2, you get, they have the same exponent, so you could just do 5.6 divided by 2.8. Let's see that. That's approximately double. 5.6 divided by 2.82, right? It's approximately, it is not approximately, it's double that of aluminum, the resistance for tungsten, right? So it's twice as great, because it's asking for, compared to the resistance of aluminum wire, which is 2.82 times 10 to the negative 8, and then the resistance of tungsten is 5.62, which is double. So yeah. How much energy is expended when a current of 5? Okay, so let's label this. We have a current of 5, and we have a resistance, let's put it like that, ohms, 5, and we have a time of 5 seconds. Okay, so we have to use again one of the electricity formulas. So we have work equals current squared times resistance times time. We have those variables. We have the current, the resistance, and the time. And we're looking for the energy expended, which means the work, right? Energy expended. So we have the work equals the current squared times the resistance times time, which is equal to, okay, 5 squared is 25. 25 times the resistance, which is 5, is equal to 125. And then 125 times 5 again is equal to 625 joules. Choice C. The amount of electric current through an unknown resistor may be measured by connecting. Well, okay. So this question is asking, how do we measure current through a resistor, right? Okay. Yeah, okay. So that means that a voltmeter is incorrect because that measures voltage. And then what's the difference between in series and parallel? Well, in series will give you a better measurement because it will measure the current, the total current flowing through the circuit, while in parallel we won't have as accurate measure because there will be many resistors in the circuit. So that's, we will have the best measurement here in A. Which phenomenon represents a wave spreading out behind a barrier? Okay, I'll draw this out, and then what does this remind you of? Diffraction, right? Spreading out behind a barrier. That's diffraction. And I mean, you could do it even, you throw something in water or in a pond, wherever, the ocean, it's gonna form waves. That's diffraction. 1 kilometer length, okay. Has resistance. Okay, so I see this, another copper wire half as long and has twice the cross-sectional area. I know which formula to use. Resistance equals resistivity times the length divided by the cross-sectional area. Well, look, we have a copper wire which is half as long, so multiply this by half. This will multiply by half. Multiply this by 2. This will be by half. A half times a half is a fourth, so basically we get 1/4 of R, right? What is the resistance of copper wire B? So this is copper wire B. A has a resistance of 0.172. So 1/4 of 0.172 give you the resistance at B. So let's do that. 1/4 0.043. Yeah. The magnitude of electric force exerted on a small positive charge located between two oppositely charged plates is the same, right? If we have two plates, the magnitude of the field strength or the force it imposes upon charges will always be the same everywhere in the plates. Doesn't matter where it is or where the charge is in the plates. The acoustic organ is a musical instrument with pipes. The oscillation of air molecules in the pipes of the organ produces sound. Okay, so this is basically a question about sound waves. So in the waves topic of waves, you have to know that sound waves, they are longitudinal and they are mechanical waves, right? They're both longitudinal and mechanical. Transverse, no, if you have like, let's say, I'll give you another example. Radio waves, they are transverse and they are electromagnetic, right? Same with light waves. So sound waves are not electromagnetic and they are not transverse. They are mechanical and they are longitudinal. Yes, it's 3. And the difference between longitudinal and transverse is like this, while longitudinal is like where it has like rarefactions is like, how do I explain it? It's like, this is not a good drawing, but think of like a slinky, right? If you push it back and forth, that's longitudinal. Which list identifies portions of the electromagnetic spectrum in order of increasing frequency. Okay, so we have to use this table. Increasing frequency, it means going from basically right to left, right? So we have to start with radio waves or whatever it is, the order, we'll see. Gamma ray, infrared, no, this is going from left to right. This is the opposite of what we want. Ultraviolet visible, ultraviolet visible, no, this is going from left to right again. Infrared visible, infrared visible, okay. Ultraviolet gamma ray, yes, it's C. Gamma ray, ultraviolet, gamma ray, no, left to right again. A tuning fork is used to produce a sound wave having a frequency of 512 hertz. What is the wavelength of the sound? So wavelength. Now we're here. We want the wavelength. So V equals F lambda. Let's write that down. V equals F lambda. Solving for lambda, you get the velocity divided by the frequency. And let's continue that on. So sound, right? Sound does not have speed. No, it does have speed, sorry, but it cannot travel in a vacuum. That's what I wanted to say. So speed of sound in air is 331 meters per second. So 331 meters per second divided by 512 will give us an answer only below 0. Only below 1. An amplified sound wave produced by an opera singer shatters a glass. This is resonance. Because resonance is basically when kind of we have a natural frequency, right? And then when it gets amplified to a certain extent that's unbearable, it shatters in this case. That's basically what resonance is. Diagram below represents a wave traveling in a rope. Okay. So we have the motion going this way, so the wave is traveling this way, right? This is the important part. If it's traveling to the right, that means our particle is going to go up. If it was traveling to the left and going in the opposite direction, it will be going down. So the answer is 4. These left and right, these are only for longitudinal waves. This is a transverse wave. If several resistors are connected in series in an electron, the potential difference. Okay. So we have the formula R equals V over I. R is equal to V, voltage divided by the current. Which means that the potential difference multiplied both sides by I. We get V is equal to I R, which means that the voltage is directly related with the current and resistance. So varies the potential difference, otherwise known as the voltage, varies directly with the resistance. Yes, this is correct. In medium X, light with a wavelength of that travels at, okay, so we have the wavelength here, we have the velocity here. In medium Y, the light has a wavelength, okay, so this is light, let's call this light wavelength 2, wavelength 1, and has this wavelength, and has, I don't know, what is the speed? So we're asking for, so let's say this is V1, this is V2. We use this one. V1 over V2 is equal to lambda 1 over lambda 2. V1 over V2 equal to lambda 1, lambda 2. Okay. So you can multiply, no, no, let's just plug in. Instead of manipulating. Okay, so we have 2.20 times 10 to the 8th divided by, what we're trying to find, V2 equals to the wavelength of the first one, 3.44 times 10 to the negative 7 divided by 3.12 times 10 to the negative 7. Okay, so we multiply, we can cross multiply. We get 3.44 times 10 to the negative 7. V2 is equal to 2.20. Okay, so we have to multiply these two. So 2.20 times 10. What was it? 2.20 times 10 to the 8th. Okay, and then multiply this by 3.12 times 10 to the negative 7. Times 10 to the negative 7. 68.64. So divide this by 3.44 times 10 to the negative 7. Okay. 3.44 times 10 to the negative 7. Okay, that's 1995, so that's basically 2.0 times, okay, yeah, it's A. Move the decimal, you get to the 8th power. 31. A nuclear reactor produces that many joules of energy per year. How much mass is converted to energy? So anytime you read this word, mass is converted to energy, that's the key word for E equals mc squared. That's what it basically means. Energy is being converted to mass because the speed of light stays the same. So E equals mc squared, right? So we're solving for how much mass? Yeah. So divide by c squared. We have the energy right here in joules, 2.7 times 10 to the 16th divided by 3.0 times 10 to the 8th squared. That's 9 times 10 to the 16, so this could simplify to 2.7 times 10 to the 16 divided by 9.0 times 10 to the 16. This this cancels, so you get 2.7 divided by 9. So 2.7 divided by 9 is 0.3. Yeah, A. Okay. Diagram below represents the initial charge and position of two identical conducting spheres on insulating stands. If the spheres are brought into contact with each other and separated. So anytime we bring two spheres into contact, we have to add up the charges and then divide by 2 to find the charge in each individual one, because they have to be equal to each other. So -7 plus 3, we can be like, and since they have the exponent, so it will be -7. We're just doing -7 plus 3, so it's -4 times 10 to the -16 coulombs. Divide that by 2, you get -2 times 10 to the -16 coulombs. That's it. An anti-muon neutrino. Okay. Now we have to go to the modern physics section. An anti-muon neutrino. So an anti basically means it's the opposite, the same mass but the opposite charge. So anti-muon neutrino. So muon neutrino is 0. Anti will just be -0, which is just 0. So an anti-muon neutrino will be, what's the question asking? A lepton. Well, it is a lepton, right? So it's not a meson. It's a lepton with a 0 charge. Yeah, because -0 is still 0. Okay. The graph below shows the displacement of a certain particle in a medium versus time due to two periodic waves traveling A and B traveling through the medium. The superposition of the two waves will cause the particles to have a maximum displacement. So superposition means when we add up the waves. So we could get any point. We could get here, right? We have to match it up here. So 3 here. So this is 3 meters. When we add these up, 2 meters here. 3 plus 2 meters is 5 meters. And these are constructively interfering because they're moving in the same direction, right? If this was opposite, going down, they would destructively interfere. Okay, last question for this. The diagram below represents a wire that is not part of a complete circuit just above the poles of two magnets. Moving the wire downward between the poles in the direction shown will... Okay, so north and south, right? These are two magnets. If we have two magnets interacting with a copper wire, right? Oh, we don't know if it's a copper wire, but a wire anyway. What will happen, direction of motion is going down, it will induce a potential difference, right? Because it's causing current, the two magnets. It creates a current in the copper wire that basically changes or affects the potential difference. So it's 2. First of all, I cannot decrease the wire's resistivity because it's just I don't know what I keep saying copper wire, but it's basically a wire. We're not changing the material or anything like that. And direction of magnetic field cannot be reversed. Induce an alternating magnetic field. No, it's not alternating. It always acts in one way. So that is it for this video. The next video will include part B1. If you have any questions, put them in the comment section. Thank you very much for watching this video.